about light. So in this topic, we'll discuss the properties of the light, the image formed by a plane mirror, and image formed by a convex lens. So first started with the first property of a light, reflection of a light. How we define a reflection? So when light strikes the surface, it bounces back. This property of a light, when it strikes the surface and bounce back, we call that as reflection. Reflection can occur with a smooth surface or as well as a rough surface. With a smooth surface, the light rays will have or directed or reflected in same direction, but in the rough, when they strike the rough surface, the light rays will scatter. So example, the change in direction when light strike the surface, we simply call that as reflection. Example, this is a reflecting surface, say a mirror. The light which strike the surface, that light is known as an incident. The light which bounce back, that light is known as the reflected light. Imaginary line which is 90 degree or perpendicular to the surface, we call that as a normal. The angle between the incident and the normal is known as angle of incidence. An angle between the incident and the reflected ray is called known as angle of reflection. And according to law of reflection, so law of reflection states that angle of incidence must equal to angle of reflection. So if angle of incidence is 30 degrees, the angle of reflection should also be 30 degrees. If angle of incidence is say 60 or say 45 degrees, angle of reflection is also 45 degrees. So according to law of reflection, the angle of incidence must equal to angle of reflection. And the property of a light to change direction when it strikes the surface, we call this property as reflection. Is it clear? The reflection of the light? Then how the image is formed by the plane mirror? So image formed by a plane mirror. A plane mirror is having a flat surface. Example, this is a plane mirror. One side of this plane mirror is smooth and the other side is a reflecting. So one side is a smooth side and the other side is a rough surface, does not reflect. Now what happens if an object is placed, if we place an object in front of the mirror, how we can explain how we are able to see this object? This is an object which is placed in front of the mirror. So what happened? Yes, by the help of the light, we are able to see this object, but using a reflection, how we can explain, we can see this object. So what happened? If this is a luminous object means it is giving out its own light, or if it is a non-luminous object, it is reflecting the light from other substance or other source. So example, the light strike the mirror, and when this light strike the mirror, it will follow a law of reflection and it will bounce back. Then there is another ray coming out from the object in different direction, that also strike the mirror, and it is also following the law of reflection. When it follow the law of reflection, it will also bounce back. So two light rays which are coming out from the object strike the surface. When it strike the reflecting surface, the two light rays bounce back. Then what happened? A person who is observing this object. So example, this is an eye. So a person who's observing this object, this is an eye. But how we are able to see this object? Our brain always sense, like example, if this is eye, our brain always sense that light is coming straight from the object. This is a sensation which is created by our brain, that light is coming straight from the object. So what happened when these light rays strike the reflecting surface and enter our eye? Our brain sense that light is coming straight from the object. So when our brain relocate these light rays, or when our brain produce these light rays back again in opposite direction, so what we observe, or what it appear that, just a minute, I will intersect these lines. Just I'll change the angle so it can intersect. So the two light rays strike the surface and enter our eye. So when these light rays strike the surface and enter our eye, here is an object. The object is emitting out light rays. This is ray 1 and ray 2. These rays strike the surface, the mirror, and it enter our eye. So when these light rays enter our eye, our brain produce an image. But how our brain produce an image? Our brain relocate these light rays and consider they are coming straight from the object. So when our brain reproduce these light rays, so these light rays will intersect at point. It's imagination of the brain. It's in reality, it's not happening. It's an imagination of the brain that the two light rays, after striking a surface, enter our eye. So our brain relocate these light rays, and it assume that these light rays are coming straight from the object. The point where these two light rays will intersect, that is the point we call that image is formed. So in reality it's not there. It's just our imagination which create an image. That is why this image is not real. We also call that as a virtual image. Virtual image means the image which is formed by the imagination of the brain. So I'll repeat. Look what happened if you have a reflecting surface. Example, if this is a reflecting surface, and here you have an object in front of the mirror. So when you are in front of the mirror, the two light rays which are coming out from the object, the black line is representing a mirror here, and mirror is having one side polished, another side is rough. So the light rays strike the mirror. Like example, this is the first light ray strike the mirror. When it strike the mirror, it will bounce back. It will follow law of reflection. But to show how the image is formed, we need at least two rays. Then there is another ray from the object, strike the surface, and it also follow law of it also follows the law of reflection. But what happened, these light rays, you can see the distance between the two light rays is increasing. So these two light rays enter our eye. So when these two light rays enter our eye, our brain always sense that the light is coming straight from the object. So our brain try to create or relocate these light rays. So our brain produce them backwards. This is imagination of the brain. So our brain produce the same light rays backwards that they are coming from the object. So when our brain produce these light rays backward, the point where it appear that two light rays intersect, that is the point where our brain will show us the image. So in reality, it's not there. Like example, if you're standing in front of the mirror, you see all the objects which are back of the mirror. So in reality, there is no object back of the mirror. It's just a virtual imagination of your brain which create all the image at the back of the mirror. So in reality, like example, if you are combing your hair in front of the plane mirror, you observe that all the things appear to be back of the mirror. So in reality, there is nothing back of the mirror. It's just our brain imagination which create an image back of the mirror. And because this image is not a real image, so we call this image as virtual image or imaginary image. So this is how the image is formed by the plane mirror. Is it clear? So what are the characteristics of this image? Number one, it is virtual. It's not real. Number two, it is same size. Like if you're standing in front of a mirror, you will find your size is same. It is same distance from the mirror. And it is laterally inverted. Laterally inverted means the left appear right. Like example, if you're standing in front of a plane mirror and you raise your right hand, so what you will observe? You'll observe for an image, it is a left hand. No, the two light rays of Afif here are not parallel. You can see they are making the angle between the two light rays. These two are not parallel light rays. The distance is increasing between the two light rays. If you raise your right hand in front of a plane mirror, it will appear a left hand for the image. So left hand of the object appear right hand for the image. So left appear right. That's called laterally inverted. No, if you raise the right hand in front of the mirror, for the image, it will appear as a left hand. So these are the characteristics of the image formed by a plane mirror. It's virtual, it's same in size, it's same distance, and it is laterally inverted, or left appear right or right appear left. left of object appear right of the image, or left of image appear right of object. That is the meaning of laterally inverted. So these are the definitions which we use. The incident ray is the light which strike the surface called incident. The light which bounce back called reflected. Angle between incident and normal is angle of incidence. Angle between reflected and the normal is called angle of reflection. And normal is always perpendicular or 90 degree to the surface. And according to law of reflection, the angle of incidence must equal to angle of reflection. There are experiments also in your course outline, experiments related to these law of reflection, refraction, so that these experiments will do in a discussion of paper 6, not now. How to carry out the experiment, that in detail I will explain. But because we are in paper, mainly focus is paper 2 and 4, so discussing the theory. The second property of a light is called refraction. Refraction means property of a light to change speed when travel from one medium to another. So when the light travels from one medium to another, it changes the speed, and we call that as refraction. For a light, it is opposite, because light does not require a medium. So when we compare the speed of the light, which one you think light travel faster? Example, we have vacuum, we have air, water, and then we have glass. Light does not require a medium. Light can travel or pass through vacuum. So speed of a light in vacuum is much faster than compared to air. In air, it is much faster as compared to water, and in water, it is much faster as compared to that of glass. Because light does not require a medium, or it can travel through vacuum, but sound require a medium to propagate. That's why sound is faster in solid compared to that of liquid, and liquid is faster than gases. The speed you have to learn, memorize this speed. Speed of light in vacuum is 300 million meters per second, or 3 exponent 8 meter per second. For air, you can say approximately, because very small change is there, moving from vacuum to air. So you can say the speed of light is approximately the same as speed of light in air is approximately same as speed of light in vacuum. But in reality, there is a fraction difference between in a vacuum, it's traveling much faster as compared to that in air. So when the light travels from one medium to another, it changes the speed, and we call that as refraction. Or bending of the wave due to the change in speed, we also call refraction. Example, this is a glass block or a transparent glass. The light which strike the surface, what we call this light, this is called incident ray. So the light which hits the surface or strike the surface is known as incident. Imaginary line which is perpendicular to the surface, we call that as normal. Now what happened? The light is in air and it is moving from air to glass. So moving from air to glass, what happened to speed? It will increase or decrease? So it will decrease or it will slow down. So as it decrease or slow down, what we observe, when the speed decrease, it tend to move towards the normal. So what happened, like example, if I show three paths, A, B, and C, which one it will follow? A, B, or C, if the speed of a light decreases, moving from air to glass. So as the speed of a light decreases, it bends towards the normal. So we will observe it bend towards the normal as the speed decreases. And the light which is refracted is called, the light which bend or slow down is known as a refracted ray. And this phenomena of a light to change the speed traveling from one medium to another, or moving from air to glass or glass to water or air to water, this property of a light is known as refraction. And same thing, the light is in a glass, we'll draw a normal again, moving from glass to back again, air. What happened to speed of the light? Increase, decrease, or remain same? Moving from glass to air. So the speed increases. If the speed increases, what happened? It will bend towards the normal or away from normal. So it will bend away from normal, and that is called emergent ray. The light which is coming out is known as emergent. So this is what happened in a refraction. The light strikes the surface, light passes from one medium to another, it changes the speed. So here, when it was in, so when the light was in air, it was moving fast, then it slowed down, and again it will become fast. And the property of a light to change speed, basically the standard definition is property of a light to change speed when travel from one medium to another. Because it is not necessary that light will always bend. If it is passing along the normal or 90-degree, then it will not bend. That's the next example. Is it clear, the concept of refraction?
You can explain it again.
The light which strikes the surface, that's called incident, and that is in air. So in air, the light is moving faster. Imaginary line which is perpendicular to the surface, that's called normal. As the light moves from air to glass, its speed decreases. So you can see it bend towards the normal or it slow down. So what we observe that when the light moving from denser, low density medium to high density medium, it slows down. And the light which bend or light which slow down or changes the speed, that light is known as refracted ray. The light which comes out or emerge out, that's called emergent ray. So basically what happened, here direction is changing as well as speed is also changing. So what happened in air, it was moving faster. So in air, it was moving fast, but in a glass, it slowed down. And again, moving from glass to air, again, it will speed up. The frequency does not change, but what happened to speed here? Moving from air to glass, so we observe the speed decreases. So if speed decreases, what happened to the wavelength? The wavelength should also decrease, so the frequency remain constant. Frequency is equals to speed divided by wavelength. So moving from, when it enter from air to glass, what we observe the speed decreases. Speed decreases, so what should happen to wavelength? The wavelength should also decrease so that the frequency will remain constant. And opposite will happen, moving from glass to air. So what we observe, as it moves from glass to air, its speed will increase, its wavelength will also increase, but the frequency will be same. Frequency of a wave or number of vibration traveling from one medium to another does not change, or it remains constant. If a light came from bottom to top, it's the same thing happen. I just changed the direction of the arrows. Like example, moving from air to glass, it will bend towards the normal, and moving from glass to air, it will bend away from the normal. It's this, and now this will be incident, and this will be emergent, the one which will come out. Is it clear? The angle between the incident and the normal is called angle of incidence, and the angle between the refracted and the normal is known as angle of refraction. That's why, like example, here in this, if you place, like you fill up the glass with water and you add, like to this water, you add or put a pencil or a ruler or a scale. So what you will observe, you'll observe it appear that the pencil appear to break. It looks bent, or it appeared that it break. What is the reason for that? That's due to refraction. Look what happened. Example, you have a container and you fill this container with water. So a container, you fill this container with water, and say a pencil or a pen or a ruler is there inside the water, and you're holding it. It's not touching the base, you're holding it. Now what happened if you're observing this point A, the base or the tip of the ruler or the pencil? So what happened, the two light rays which are emerging out from the water, as it travel from water to air, it will bend away from the normal. Same thing, another ray, it also bend away from the normal. So if you are looking or observing from this point, so what our brain sense, our brain always sense light is coming straight from the object. So when our brain relocate this, position, so what it appear that the tip is at this point. So this is just our imagination. In reality, the tip it does not bend. It is not reflect, it is refracting. This is called a refraction. There are light rays in near your surrounding. You have a source of light. So the light rays which is at the surface, which is strike the surface of this tip, it's refract or bend away from the normal. So when we are observing, our brain sense light is coming straight from the object. So when our brain relocate the position, it shows that the tip is at this new point, say A dash. Originally it was A, but A dash. This is a new position where what our brain imagine or create, and due to this imagination, it appears that the pencil or a pen or a ruler is bent or it breaks. But in reality, it does not happen. It's just our imagination. It's a virtual image which is created by the brain. That's why, like example, this is a very common example. When you're looking at a swimming pool which is filled with water, so when you're looking at from outside, when you look at the base of the or the bottom of the pool, it appears to be shallow. But when you enter, in reality it is deeper. Because why it appear like this? Due to refraction of the light, our brain create an image that the bottom of the pool is bit closer, but in reality it is deeper. Is it clear, the concept of refraction? So property of a light to bend when it travel, or property of a light to change speed when travel from one medium to another, we call that as refraction. You can do this simple experiment. Take a glass, fill it with water, put a pen or a pencil inside, and observe the nib of the pencil from other side, and you will find that it appear to be bent, and that's due to refraction of the light. So basically what happened here, say an object, a pencil or a pen, inside you put inside a container which is filled with water. So the two light rays, example, you are observing a tip. So to observe something you need a light. So the two light rays which are either coming reflected from the object inside strike the water to air boundary, so they bend away from the normal. A second light ray also strike, it also bent away from the normal. Then when you're observing, our brain always sense that the light is coming straight from the object. So when our brain relocate a new position for the tip, and what it appeared due to this new imaginary position, it appeared that the pencil is bent, and that's due to refraction of the light. In reality, pencil is not bent, but it appeared to be bent due to refraction. Is it clear, the concept of refraction? Then if a light is coming straight from the object, like passing along the normal, different examples of refraction I'll give, so you have a better understanding. Like example, if it was why a swimming pool appeared to be shallow. Look, example, this is a swimming pool which is filled with water. Sorry. So you are observing this point. Okay. Example, you are observing point A. So to observe anything, there should be a light rays either coming out from the object or reflected from. So if I consider the two light rays which are coming out from this point or reflected by this point, so as it travel from deep to shallow, sorry, as it travel from high density to low density medium, speed increase, so it will bend away from the normal. So as it bend away from the normal, and you're observing from this side, so what happened? Our brain recreate the position. So when our brain recreate the position, or relocate the position, so what it appear? it appears that the point A is at this point. In reality, point A is not at this point. This is our only the sensation or the imagination which the brain is used to produce the image. So it appeared to be at this point. So you can see the point A was on the base, but now point A appear above than the base. So that's why the swimming pools appear to be shallow, but in reality it is deep. Is it clear? Then refraction for a semicircular glass example, or if it's a rectangular glass, but the light strike 90° perpendicular. So if the light strike along the normal, it will not change the direction, but only thing what we observe that it changes the speed. So if the light, so if light strike the surface at normal or perpendicular, so if a light strike the surface normal or perpendicular, what we observe the only thing what change is the speed. So here in air it was moving fast, this slow, and again it is fast. So speed of the light only changes, but the direction of the light does not change. So only in this case, speed will change, but the direction will be unchanged. So whenever it strikes along the normal, there is no change in direction. But this is also called refraction because the definition of a refraction is a property of a wave to change the speed when travel from one medium to another. So we studied three types. We studied the refraction of the water waves. For water waves are faster in a deep region and slower in a shallow region. The second one is about the sound waves. So sound waves are faster in denser medium and slower in a less dense medium, like in solid it travels faster than in gas. But for light it is opposite. In vacuum or gas is faster as compared to that in solid or liquid. Is it clear? Another example for a refraction. This refraction, I just recall the idea of a refraction. When the light rays, no, it changes the direction. If it is traveling along the normal, it does not change direction. If it is not traveling along the normal, you can see here it is not traveling along the normal, so it changes the direction. If it